So my name's John Parello. I'm from Cisco, and the first thing you're thinking is probably, Cisco? Why the internet people here? Like, what are we doing here at AI stuff, and why the plumbing people are here? I'm a principal engineer, and I'm here to talk to you about AGNTCY, which is our open source project for building multi-agent systems. Big mouthful, but what we're trying to do is go the opposite end of the scale of what you just saw. We're trying to take multiple agents and put them together at a global scale to build applications. So you can kind of think of us as trying to build these giant global enterprise systems with agents, when what you just heard from was like, okay, we're trying to scale out the actual agents. So I'll try to put it in context and see how we're building multiple agent systems. The group I come from is Outshift, so yes, we're a big company, we're a big internet company, but we're the small incubation arm inside of Cisco. So we incubate things while trying to disrupt the company, and one of the things that's coming around, obviously, you know, is AI and agents. All right. First thing is, everybody goes, what is an agent? I think some of the talks you heard today, you're saying that, well, agents are software or agents are LLMs. What is it? Is it a software module? Is it a software component that we're trying to scale out? And we already know how to do that. But that would be like turning the clock back to maybe 1920 and saying, we know how to build roads on cars, and not even thinking about what it's going to be like when we have autonomous roads in the cars in 2025. So you can have an LLM that is wrapped in software, or you can have an LLM that has the agency, pun intended, to communicate with other agents. But how is this going to scale? Are we just going to use this as software, or are we going to use these as full first-class AI agentic LLMs that are going to be communicating with each other? So what is it going to be? We don't know. So what we've been doing is we're saying, how do we go at scale? So Cisco, we're a networking company, but the one thing we know how to do is scale. You never heard us say like, well, you know, I'm trying to send a WhatsApp message to you, or I want to send a text message to you. It's better to go in one platform and another. You don't go with that with the internet. You don't say, oh, I'm going to go through the Cisco part of the internet. It doesn't work that way. You go over the internet. We stay decidedly neutral, and we're trying to stay neutral when it comes to building agents. So one thing that we do know is that we do think that agents, whether they are software with LLMs contained in them, or some sort of LLM at the base communicating, they will communicate with each other, and they will be subject matter experts, and they will come from different vendors, different frameworks, different clouds. As much as the cloud providers and all the software folks are telling you, just come with us, come on our cloud over here. I know the big bookstore is going to tell you, yeah, we're going to come on ours. What we know is that in practicality, when we try to do these things at global scale, it is a mixture of all of them. It's a mixture of on-prem, multiple clouds, and they are going to come from different organizations, and they're going to have different profiles and persona, which some of the people talked about previously, about how they try to get identity and things like that. So what we saw right now, and this happens a lot, the market is today, and everybody here, what we're doing is we are working on using agents with tool calls, and just about everybody here is doing that, taking agents and tool calls to do a specific job. About 90% of the people on the planet are doing that now who are in this space. Maybe 10% of them are using the frameworks to take multiple agents and make them talk to each other. How many people are taking agents and putting them on a global scale and deploying them for their mission-critical systems? Not yet. But they will be, and the thing is, usually if you tell people what the future is going to look like, they usually burn those people. But Cisco, we've seen this movie before. Wright brothers fly an airplane, they make it go. Somebody does a proof of value. That's probably where we are now. People are saying, yeah, I can make a business out of it. Talk to me when you're at scale for how many X thousands of flights per airport in a global system of airports that all have different vendors, and sound familiar? Different vendors, different standards, different identities, and it all works together with no central authority. That's the internet. We've seen that happen with wireless. We've seen that happen with the internet, telephony. So we've seen this movie before. So when we started looking at agent development, we said, all right, people can build one agent that has tool calls, great. I can build an agent that has models where they're using MCP to go towards extended tools. Then you can also say, all right, I'm going to take that, and I'm going to make that be the agent communication. So from Anthropic, absolutely, you can use MCP to have two models talk to each other, but at its base, that's still a tool call, not agent-to-agent communication. What happens if I take a bunch of these and I zoom out a bit and I say, well, that's a microservice that now I'm going to have to deploy in Brazil, Colombia, haha, Tatooine, or I'm going to have a whole bunch of MCP servers that I'm going to have to get to from a registry. What kind of communication am I going to use in the middle? And the state of the enterprise systems and global systems is we're using transports that are based on PubSub. You could have NATS, TIBCO, Kafka. There's all different kind of protocols for that. And what we realized when we started building systems, whether it's the internet or airports or anything like that, that we have to have some sort of areas where we need to work on. So what we decided at Cisco was, let's look at this the way the internet was made. It's sort of at the IETF, we had working groups. And the fact that this movie is running so much faster than we've seen it done before, we can't take something to the standards and then write code for it like we used to. So what we thought is, let's look at these working groups and say, agents must have an identity. They need to have a signed identity. But where is that going to come from? That's going to probably come from different IDBs, like Okta for Cisco, for Duo, and they're going to have different ways of doing that. They have to plug in and work together. We're going to have a catalog of the capabilities of an agent. If a government agency wants to use an agent that came from a vendor and it does video, hashtag video is not going to cut it for that. They're going to want it to be certified on a specific skill in order for it to come in. So we'll need a catalog of skills. We'll need a directory of running agents. I might have an agent that runs Salesforce data. Well, I might have 15 of them. Which one? From my division, from a different company. Which one am I going to run with? I'll need a directory of that. The area in the middle, that's where everything's going on now, where you see a lot of talk about semantics and transport. So how are agents going to be communicating with each other? Well, you can come up with semantics based on JSON, and guess what? A2A kind of won that one. A2A is becoming the default semantic for agents to speak to each other. But then what transport are you going to use? You're going to use HTTP, gRPC, again, Kafka, TIBCO, PubSub. How are we going to do that? And then once you do have the agents brought together, what kind of workflow are you going to have? Are you going to have agents that are going to be prescribed where I go from one agent to another? Or will they all come together, and as we saw, are they going to be communicating over a Slack channel or some sort of channel where they're doing a group communication and figuring out the work on their own? And then, please God, we've got to be able to have the observability on this stuff. So we want open telemetry from the top all the way down to the networking level and then link it all together. So we need work in open telemetry, and obviously we need security. So we're going to need encryption. We're going to need role-based access. Again, what is the identity of the agent, and then what skills or what role can it take on based upon the task at hand? So all these things have to be addressed. So what we wanted to do is bring order to it, because we've seen this movie before, and say, let's open up an open source consortium to put code in for each one of these. But if it winds up that the code we put in isn't the one and there's something else, we'll substitute it out. For example, we came out with ACP, a different ACP than the IBM one, which was Agent Context Protocol, and we thought that would be the way that agents would talk to each other. At the same time Google came out with A2A, we said, great, drop that one, we'll go with Google. So we would get together and we would just say, okay, take the things that we had and contribute it back in, because we want the working group, we want the group to win, not the specific protocol, right? Because we want to stay decidedly neutral. So what we did is we founded the group, we seeded it with code, we went around and got 75 organizations, got them together, and then with the formative partners of Cisco, Dell, Google Cloud from the A2A group, Oracle, Red Hat, we formed the agency working group in the Linux Foundation, donated the code, and we want to be the working groups for agent-to-agent communication. So we have people working in the different categories in there, and we have working groups for there. We have an identity working group. We have our giant core working group, which is doing all the ones in the middle. We're probably going to break those out. And then we have the observe and eval working group. And then underneath, we have coffeeAGNTCY and App SDK. coffeeAGNTCY. All right. That sounds weird, right? All of a sudden I just said coffee. All right, if you know about CNCF, if anybody's ever used the sock shop, that's like our equivalent of the sock shop. So what we did is we tried to pick the type of system, a type of global system that are the hardest to do, and those are supply chain. That's used in academia for proving out algorithms, but we also know from putting this out on the planet scale that supply chains have the most independent actors and have the most logistic concerns. So what we did is we came up with a coffeeAGNTCY, a coffee conglomerate, to use as an example, because the best way to know if something is going to work is to go do it. And that's what we're going to do. We're going to try out these things, try them out on the applications, and then see which one works. So if we have two different types of transports, two different types of observability, can they work together? We're going to try that out. And what we did is we have an application SDK that runs across the top of it. And we're decidedly open about it as well as the components that go underneath. So we're going to be, just like you were seeing before, you could pick different models. What we're trying to do is say, well, if you want to try one transport for NATs, or you want to try another transport and use ones that we've made up, there's one called Slim, which I'll talk about, we can try them out and see how they work at scale. So I'll show you an example. For the code that I have here, we're just showing how you can pick, you could do A-to-A. You could say, I'm selecting my semantic, and then I'm selecting the transport. And for here, we're picking the transport Slim. That could be HTTP, it could be gRPC, and I'll talk about Slim. It's a protocol that we're putting in into the agency foundation. That's, if you think about it, it's kind of like a communication protocol for group communication. And what we figured is we'll have these factory methods to try them out so we can try the different agentic patterns at scale. And you would have this SDK so you can work either locally, or if you have the capacity to try this out at scale, you can try deploying them in different areas. So the thing that we're looking at is, like, when it comes to protocols, we love all the different protocols. We'll try MCP over HTTP, or MCP over gRPC, or A-to-A over Slim. We'll try out the different protocols in the middle, but we're also going to try out all of those different things that I talked about, like identity. So to go into something that we talked about with, like, communication protocols, again, you have A-to-A, and A-to-A can do a request response, that's HTTP. But that's not going to cut it for every type of communication. So you might want to do unidirectional streaming, where you're saying, hey, I'm streaming a lot of output that's coming in from an agent. Well, that's going to be a gRPC based. If I want to do bidirectional streaming, I'm probably going to want to do gRPC for that. If I want to do publish and subscribe, that's where I'm going to want to do NATs or Kafka or something like that. But there's a new pattern that's coming up where you want to do a group communication, where you want a bunch of agents to come together and talk about a problem, have a shared channel where they can discuss things, and then they can have a shared context. Now, you see some people using Slack, or you could use Discord, but that's a heavyweight protocol all the way at the application level. And at Cisco, we're kind of like, if you do that, we can't help you optimize or isolate the traffic or actually optimize the traffic if you're going at such a high level. So we think that needs to be brought down a little lower. So we came up with a protocol called Slim, which does all of these patterns, plus it does secure group communication protocol, which is, again, you could think of it like a Slack or something like that, but at a much more efficient level using MLS. And you can imagine, if you go in on any kind of like a Zoom call or a Google Meeting call, if you are all talking to each other and the latency gets bad, you kind of lose the context, right? Well, if the latency gets bad on a connection and you're doing critical kind of transactions between agents, they can fall behind, and then you're wasting a lot of compute time for that. So we're saying that we need a better protocol for that. That's one area where I'm zooming in saying, look at what we have to do for just the transports. Imagine what now we have to do for identity. We have to do the same thing for observability. So each one of these working groups, we're trying to zoom into the problem and say, what happens when we take this at scale? What happens when we have all of these agents working at a larger scale? So what we did do is the reference application that I talked to you about, coffeeAGNTCY. When somebody goes to our repo, you can get two types of setups, a small one and a large one, a Corto and a Lungo. Corto is a simple two-agent setup, where it's two agents talking to each other, so you can try this disconnect and use two different frameworks if you wanted to for agents to communicate with each other. They're very basic things that you would do if you just want to learn this. Our Lungo one, that's the one where we're going to systematically walk through all of the types of use cases that we have in the supply chain and try to come up with all of the agentic patterns. Just like we used to do software patterns, we're going to go through and do multi-agent patterns and say, what happens when we want to do persistence? What happens when we want to interrupt? What happens when we want to have a shared context? What happens when we want to have a shared communication channel that everybody's speaking over? We're going to go through all of those specific patterns. So I'm going to go and try to do something live here. and show you the actual live one. Now, when you go into the repos, you can run this yourself. You'll see the agents running. You'll actually see the 2 agents running, and you'll get it from the CLI. We popped up the user interface because it's not showing. Yeah, I knew that was going to happen. Let's see if I can get to show there. Nope. It's always PowerPoint. There we go. Okay, cool. All right, hopefully you can all see that then. Okay, great. So basically we have this user interface that comes up and shows you the setup of the 2 agents. And right here we're doing an 808 semantic over the SLIM protocol, and we have 2 different agents in there. We just did a supervisor and a sommelier, and we can just say, go take one of the suggested prompts that are there, but you can do any kind of a prompt, and you can say, show me the flavor profile of Ethiopian coffee, and hopefully that still works. If not, I'm gonna have to go to my video. And yeah, it runs back and gives you the results. But that's just so you can learn and try to do 2 agents working together. What happens when you want to do a multi-agent system? And what we've done is we've set it up that on the left-hand side, we're going to go through all the different agentic patterns and keep adding it. So we need people to come on in and help us on the open source to get all those different patterns and see how we can have these agents running. So what we're doing here is we have a supervisor agent that's using NATS as a transport layer, which is very easily done for publish and subscribe. And we have 3 different agents, and we've named them Brazil, Colombia, and Vietnam. The idea there is, yes, you could run that all locally, but the way we're running them at scale is we are literally running that in a different location. We'll run that on-prem somewhere. We'll run one in Google Cloud. We'll run another one in another prem. And we're working with large system integrators so that we can actually see these things running in multiple data centers on a larger scale. And what happens is, if I ask a question, in this agentic pattern, we're saying, in the context of coffee buying, well, we're having an auction. We're saying, can I buy some coffee? But really, what does that mean? We're showing you the publish and subscribe pattern over 808 NATS. We can then experiment and say, oh, what happens if we do 808 over Kafka, or 808 over TIBCO, or fill in whatever one you want? So one of the suggested prompts that I could put out there is I could say, what is the current inventory? So I'm doing a broadcast out to all of them, and then they're all going to reply back. And it's a normal publish and subscribe. Yes, we can do that with software. But that's like saying, yes, we can drive on roads, but what happens when all of the cars are self-driving? It's a completely different thing that's going to happen in the behavior of the system, and we're not going to know what that behavior is until we actually try it out. So in this, we're trying to show that we can have things built in different frameworks. We can also have things having different tool calls. The Columbia farm has MCP server. It could have n number of MCP servers, and this can get as complicated as you like. The other pattern that we're showing is this is the group communication one, and this is the one that we did with SLIM. So what we did here is they are all on a same shared communication channel. They've all signed in with their identity. They've all signed in on with encryption on the communication channel with MLS. And we have a buyer, we have a shipper, we have an accountant, and we have a logistics server. And what happens is, and the Tatooine farm where we're going to get the coffee from. And it says, I want to order coffee at $3 per pound for 500 pounds of coffee from the Tatooine server. And hopefully that goes. All right, please go. Okay, so the idea there is each person is going to be then saying what happened on the transaction onto the bus. So it's just going to say, I didn't refresh. That's always happens when you do live. Try that again. All right. I didn't want to do a can demo. Yeah, okay, cool. So he's saying, I want to buy $3.50 a pound for 500 pounds of coffee. The buyer says, I want to buy it from the farm. Everybody's just announcing what they did. The farm's like, I'm done. The shipper's like, oh, wait, you're done with it. I better go and fill out the paperwork. Then the accountant's like, oh, that was done. I can go and pay. And then the shipper says, oh, now that you've paid, I can go and take that shipment and process it. But all of this was not prescribed. They were all just broadcasting back and forth so that then they can get the work done. So this is what we're supposed to be doing when agents start to work together. So what we're doing is trying to put out that so that we can try these patterns, and then we can show you how they're working, and then actually install these over large areas and put in all the instrumentation. I don't have an example of it now, but all of this is done with open telemetry. So we can see the prompt calls all going into a ClickHouse database and then coming back in Grafana, and you can see all the trace calls. If you want to go and look at the agents, you can then go in and say, well, give me the actual code for it. So we left this user interface so you can go and see how we implemented each one of the farms. And if you go back in, we have a directory service where we're saying, okay, if I take a look at one of the agents, let's get a good one, then I actually have a record for it. And I go to Columbia, I can say, oh, well, here is the skills definition of that agent. That's the class definition, if you will, of the agent. It shows the skills and its capabilities. And then I can see the running instance. And if you take a look at back over here, we have a badge on each one of them that says, oh, it's been identified, it has an identity, so that if we want to try out an example where we say, oh, I want to buy from a farm, but the farm doesn't have a signed identity, the application logic can go back and say, oh, no, I can't do business with you. The accountant, if you will, might turn around and say, oh, no, I won't pay you. Right? So these are the kind of things that need to be put back into the working group so that we can try this out at scale. So everybody's coming in with these ideas. We're like, well, let's show it working. Then we'll take it to standards bodies or things like that, but we want to get the code working first. So if I go back to where we're at, the idea then is to build these applications and then have everybody work in agency to come and try these things out. So if you want to try the SDK, you can try it out and build systems like that. You can try the coffeeAGNTCY SDK on the resource pages. And I also have links in here and stuff for the repos, the GitHub repos, and for the groups. So we're encouraging everybody to come in and work with us because this is where we're going to try all the things out and see if they can work at scale. Okay? And a shameless plug is we also have tomorrow, we have a summit too tomorrow here. So if you guys want to find out more about it, we'll have panel speakers and we'll go into depth, into more detail on some of the different components. I went quickly because that's just my nature. But I just want to see if there's any questions. The idea here is just try to have the proper working groups and have the code running so that we can show the proof of value and show that this can actually work at a planet scale. We're not interested in like 2 or 3. We're like the pets versus cattle. We don't have pets. We want to know what we have when we have thousands and hundreds of thousands of these things. Okay? Okay, any questions? Cool, so everybody join up and help. Yes, go ahead. I'm sorry?
I mean, what's your technical target? What's the next steps?
Oh, what's the next technical steps for agencies? So we've been doing these things with just the LangChain and with Interoperable. We want to try local models. We want to try more models, right? Because a lot of times we start running them, we're like, that didn't quite work on this hardware platform. And so one of them is to do multiple models. The next thing, a lot of the things come down to communication protocols in the, there's work in just about every working group that we have. The identity is a whole area of research that we have on there, which is trying to come up with the identity of the agent and then also the role. So I think we talked about it. In OAuth, they're working on giving a tree of capabilities, of roles that you can do in the authorization. And we're like trying to work on that. Well, okay, is the agent going to be using that? Or is that going to be working on behalf of them? So there's work going on an agency. The directory is interesting technically in that some of the agent directories we're looking at, yeah, they could just be MCP servers, but in order for this to work, we think it should be a globally scalable directory, almost like DNS. Okay, we're Cisco, we're the networking. We like that, right? We want an open directory of all of the agents that could possibly be running. And how's that going to work in a distributed manner? Is that going to work with some sort of a blockchain, or how's that going to work when we have distributed directories, keeping them up to date? So there's work there. The semantics and transport, the semantics gets really interesting in that right now the semantics are just about message passing, but the semantics are going to get much more complicated when it comes to agents communicating with each other on a task and then having the conversation at a higher level as opposed to just passing prompts back and forth. Because you could just do that with get and post, right? Now, if you want to leverage the fact that you're dealing with LLMs, and then you can have a better semantic discussion. There's areas of research in the transport in that we want to make sure that the group communication can be signed and low latency. So there's a lot of work going on with that when people come and leave. Workflow and observability. Workflow, again, are you going to have an agent that is going to be dictating the workflow? What happens if you have a shared context in the workflow? Are we all putting information in, and then where does that information go? Who's storing that? Or am I getting links to other information that I transiently can communicate with? Observability is how do we take open telemetry to the next scale and bring it up so that we can have traces all the way from the prompt down to the networking layer, right? And security, there's always things on security as far as encryption and post-quantum encryption on this as well. There's a bunch, is what I'm saying. Really, it's like we don't have like one thing here. We're trying to do a big problem, and there's a lot of research in different areas that's going on.